The project involved transporting and placing 24,000 tons of rock to reinforce sea defenses and prevent coastal erosion. A total of 20 barge deliveries were made at high tide, ensuring efficient transport of materials to the beach location. The barge, Charlie Rock, with a gross tonnage of 2,108 tons and a maximum load capacity of 3,000 tons, was used to transport large rock deliveries for coastal defense construction. The project spanned a 5.5-kilometer stretch of Norfolk coastline between Happisburgh and Winterton, focusing on strengthening sea defenses to combat erosion and flooding. This extensive area required detailed planning, precise rock placement, and reconstruction of groins to ensure long-term protection of the shoreline and surrounding infrastructure. Rocks delivered by barge are carefully recovered and positioned at low tide to ensure stability and accurate placement during construction. Beaches were thoroughly surveyed for unexploded ordnance, UXO, to ensure safety before construction, using specialized detection equipment and expert contractors. MACC International, the UXO contractor, was responsible for surveying and clearing the site of unexploded ordnance, UXO, to ensure safety during construction. Their expertise included advanced detection techniques, risk assessments, and safe removal or disposal of hazardous materials. The project involved adding 11 rock tails to existing groins as part of the coastal defense strategy. These rock tails were constructed by placing heavy rocks at the seaward ends of the groins to enhance their stability and effectiveness in reducing coastal erosion. The additional rock structures help to slow down wave energy, trap sand, and maintain beach levels, providing long-term protection against shoreline retreat. 15 existing groins were removed and completely reconstructed to improve durability and effectiveness in controlling erosion. "11 navigation markers were replaced along the coastline to enhance maritime safety. These markers guide vessels, ensuring safe navigation in the area, particularly near construction zones, while maintaining operational effectiveness."
Firstly, the mold components are thoroughly lubricated to ensure a smooth and easy release of the finished tetrapod. This step is critical to prevent any potential damage to the product during demolding. Next, the assembly of various mold parts takes place, creating a cavity that corresponds to the desired shape of the tetrapod. The precision in this assembly process is crucial to achieve the desired final product specifications. Once the mold is prepared, hydraulic concrete is poured into it. This specialized concrete mixture is designed for underwater applications, ensuring durability and resistance to harsh aquatic environments. To eliminate air bubbles and ensure a dense, uniform structure, the concrete mixture is compacted using a vibrator. This step enhances the tetrapod's strength and longevity. After pouring and compaction, the tetrapod undergoes a curing process to allow the concrete to achieve its optimal strength. This period of maturation is vital to ensure the product's durability in its intended environment. Following curing, the demolding stage carefully removes the tetrapod from the metal mold without causing any damage or deformation. Calais Port 2015 is an iconic French infrastructure project that has left a lasting mark on the country's coastal landscape. Among its many remarkable features are the massive X-shaped concrete structures aptly named Xblocs. These structures serve as the first line of defense against the relentless forces of the sea, protecting the embankments from the ravages of swells and storms. The manufacturing of these Xblocs is a crucial aspect of the project's success, requiring precision, quality control, and cutting-edge technology. The Xblocs, as the name suggests, are formed in the shape of the letter X. This unique design was given by the owner of the DMC patent, and it plays a pivotal role in the project's overall strategy for protecting the coastline. To meet the demanding requirements of this project, an automated Xblock production plant was conceptualized and brought to life by APs, a department of the renowned French company CBE Group. This production unit was strategically installed directly on the Calais Port 2015 site, streamlining the manufacturing process and ensuring proximity to the construction site. The Xblock production plant consists of various well-defined spaces, each subjected to regular safety checks to guarantee a secure working environment. The manufacturing process begins with aggregates, which are stored and organized based on their particle size distribution. These aggregates are then transported to the concrete plant, where they are meticulously blended with cement and water to create the concrete mixture. Stringent quality control measures are in place throughout the process. Samples of fresh concrete are regularly analyzed in a laboratory to assess their properties, ensuring that the quality and traceability of the concrete remain impeccable. This rigorous quality control helps maintain the structural integrity of the Xblocs, a critical factor in their effectiveness as coastal defenses. Once the concrete mixture is deemed ready, it is dispatched to the pre-manufacturing plant, where it is poured into molds of various sizes. This production line is highly efficient, capable of casting between 28 to 40 Xblocs per day, depending on the desired dimensions. The plant can manufacture Xblocs ranging from 4 to 14 cubic meters in size, offering flexibility to meet the project's diverse needs. After the concrete is poured into the molds, they are automatically conveyed to a drying line. Here, the concrete cures until it reaches the necessary hardness to be safely removed from the molds. The molds are then cleaned and greased to ensure they can be immediately reused, optimizing production efficiency. The curing process typically takes around 2 days, during which time the blocks become sturdy and ready for transport. A stacker is employed to move the cured Xblocs to the temporary storage area, where they await their final destination. Notably, not all Xblocs make it to the final storage area. Strict quality control criteria set by DMC, the patent owner, must be met. Blocks that meet these criteria are deemed suitable for the project's purposes and are moved to the final storage area. This area can house over 1,600 Xblocs, demonstrating the scale and ambition of the Calais Port 2015 project. Transportation of the Xblocs is a highly specialized process designed to meet the project's unique requirements. A specific frame has been created to facilitate the movement of these massive structures. To ensure that each Xbloc is perfectly positioned, a gyroscopic unit known as bib is attached to it during transport. This advanced tool, combined with an acoustic camera, allows the team to monitor the block's roll, pitch, and direction with precision. The final positioning of each Xbloc and its interlinking with neighboring blocks are meticulously documented and validated by DMC, the patent owner. This rigorous testing process, which begins during pre-manufacturing and continues until installation, is essential to ensure the stability and long-term durability of the entire coastal defense structure. The construction of the Clump Point Jetty by the jetty specialist marks a significant milestone in the development of boating infrastructure in the region. This project encompasses the design and construction of a state-of-the-art concrete jetty, aluminum pontoons, and a concrete floating walkway, aimed at enhancing accessibility and safety for boaters and pedestrians alike. The concrete jetty is the central feature of this project, serving as a secure docking point for boats of various sizes. Its robust construction ensures durability and longevity, withstanding the harsh marine environment. This jetty is a crucial addition to the Clump Point area, facilitating easy embarkation and disembarkation for boaters, whether they are local fishermen, tourists exploring the Great Barrier Reef, or marine researchers. Complementing the concrete jetty are the aluminum pontoons designed for versatility and ease of use. Aluminum's corrosion-resistant properties make it an ideal choice for a marine environment, ensuring the longevity of the pontoons. These pontoons provide additional docking space and increase the jetty's capacity, allowing more vessels to use the facility simultaneously. The concrete floating walkway connects the jetty and pontoons, offering a safe and stable pathway for pedestrians, enhancing the overall accessibility of the area. This walkway ensures that visitors and boaters can move seamlessly between the land and their vessels while enjoying unobstructed views of the picturesque Clump Point. The Afsluitdijk, a historically vital piece of infrastructure in the Netherlands, is undergoing a comprehensive revitalization. Notably, it is being raised to new heights and receiving a fresh top layer to bolster its resilience against the forces of nature. To achieve this, an astonishing 70,000 state-of-the-art blocks, each weighing approximately 6,500 kilograms, are being meticulously installed along the dike. These blocks serve a dual purpose. They act as a formidable barrier against the ferocity of severe storms, breaking the waves to protect the surrounding areas, while simultaneously preserving the iconic simplicity of the Afsluitdijk's appearance. One of the most groundbreaking aspects of this endeavor is the creation of the Fish Migration River. This winding watercourse spans the entirety of the Afsluitdijk and represents an ambitious initiative to re-establish the connection between the Wadden Sea and the IJsselmeer. Anticipated to become a bustling thoroughfare for migratory fish, including species like sea trout, salmon, river lamprey, eel, and flounder, this development promises to be a boon for the regional ecosystem, fostering biodiversity and ecological balance. To complement these enhancements, the construction of additional discharge sluices and robust pumping stations in Den Over is underway. These critical facilities will enable the controlled release of excess water from the IJsselmeer into the Wadden Sea, irrespective of weather conditions. This strategic approach serves as a safeguard against the ever-present threat of flooding in the areas surrounding the IJsselmeer, ensuring the long-term protection of both infrastructure and communities. The Keenly Supply Base (KSB) project is a strategic maritime infrastructure initiative located in Turkmenistan, designed to support various industries, including oil and gas, maritime transport, and logistics. EPCC of the North and South Breakwaters is a fundamental component of this project. Breakwaters are essential for providing shelter and protection to vessels and infrastructure within the port area. In addition to the breakwaters, the project encompasses several critical elements. Quay wall. A quay wall, also known as a berth or wharf wall, is a structure that extends along the shoreline and provides a platform for vessels to load and unload cargo. The quay wall is a crucial component for the efficient operation of the supply base, ensuring safe berthing and handling of vessels. Wharf. The wharf is a raised platform constructed adjacent to the quay wall, serving as the interface between land and sea. It plays a pivotal role in cargo handling, storage, and transportation between vessels and the onshore facilities. Mooring facilities. Mooring facilities are an integral part of any maritime infrastructure project. They comprise berths, bollards, and other equipment necessary for securing vessels in place, preventing drifting or damage during loading and unloading operations. Access roads. Efficient access to and from the supply base is essential for seamless operations. Access roads connect the supply base to the existing transportation network, ensuring the smooth flow of goods and personnel. Temporary works. Temporary works include various structures and facilities that support the construction and initial operation of the supply base. These can include temporary berths, storage areas, and access roads used during the construction phase. Beacon light. Beacon lights are navigation aids positioned on or near breakwaters to guide vessels safely into the port. They are vital for ensuring safe navigation, especially during adverse weather conditions or low visibility. Auxiliary works. Auxiliary works encompass various support structures, utilities, and services required for the functioning of the supply base. This may include power supply, water distribution, sewage systems, and more. The EPCC project at Kienle Supply Base holds significant importance for the following reasons: economic growth. The construction of the supply base and associated infrastructure is expected to stimulate economic growth in Turkmenistan. It will create jobs, attract investments, and boost trade by providing a reliable and efficient gateway for goods and materials. Length and configuration. The breakwaters are designed to provide shelter and protection to vessels within the port area. The north and south breakwaters are constructed in a manner that optimally shields the port from prevailing winds, waves, and tidal forces. Materials and design. The breakwaters are constructed using durable and environmentally friendly materials to withstand harsh marine conditions. They are designed to minimize wave energy and create a safe harbor for vessels. The quay wall and wharf are constructed using reinforced concrete or other suitable materials, ensuring strength and durability. The wharf is equipped with cranes and other cargo handling machinery to facilitate efficient operations. Depth and berthing facilities. The depth alongside the quay wall is designed to accommodate a range of vessels, including large cargo ships and oil tankers. Berthing facilities are equipped with fender systems to protect vessels during mooring and unmooring. Berths and bollards. The mooring facilities include multiple berths with bollards spaced at regular intervals. These bollards are designed to withstand the high forces exerted by vessels during mooring and loading/unloading operations. Fender systems. Fender systems are installed along the quay wall to absorb kinetic energy and protect vessels and the infrastructure from collision damage. The access roads are constructed to high standards to accommodate heavy transport vehicles. They are designed to facilitate the efficient flow of cargo to and from the supply base. Temporary works. Temporary berths, storage areas, and access roads are established to support construction activities. These facilities are dismantled or repurposed as the project progresses. Beacon light and auxiliary works. The beacon light system includes high visibility lights and navigation aids to guide vessels safely into the port, especially during low light conditions or adverse weather. Auxiliary works. Various auxiliary works, such as power supply, water distribution, sewage systems, and security infrastructure, are put in place to ensure the smooth functioning of the supply base. Anticipated benefits. The EPCC of the North and South Breakwaters, along with associated works at Kienle Supply Base, is expected to yield a range of significant benefits. Enhanced port operations. The improved infrastructure will enable more efficient loading and unloading of cargo, reducing turnaround times for vessels and enhancing overall port productivity. Job creation. The construction and operation of the supply base will create jobs in various sectors, benefiting the local economy and providing opportunities for skill development. Economic growth. The supply base will attract investment and stimulate economic growth in Turkmenistan, generating revenue from trade and related activities. Safe navigation. The beacon light system and breakwaters will enhance the safety of navigation in the Caspian Sea, reducing the risk of accidents and environmental damage. Regional connectivity. The supply base will serve as a vital link in regional trade networks, facilitating the movement of goods between Turkmenistan and neighboring countries. The engineering, procurement, construction, and completion (EPCC) of the North and South Breakwaters, along with associated works at the Kienle Supply Base in Turkmenistan, is a significant infrastructure project with far-reaching implications. It will not only enhance port operations and economic growth, but also contribute to the safety of maritime navigation in the region. The successful completion of this project will mark a crucial milestone in Turkmenistan's efforts to expand its trade and logistical capabilities, further integrating it into regional and global markets.